Hello again. I'm Professor Aaron Albert. Let's learn some economics. So today we're going to talk about how we would graph supply and demand curves and how we would get them from numerical demand and supply. We're also going to learn about how to find and justify equilibrium prices and quantities, and also illustrate how change in supply and demand change our graph of supply and demand. In short, we're just going to do a hasty review of all the things you probably already learned from your principles in economics. So first, we should start with the, quote, quantity demanded. We're going to start here because this is the most concrete and most easily observed and measured of the demand measures. Quantity demanded is quite literally that. It is the quantity of some good, say salmon fish, that people have demanded. So the first thing we should question, though, is what sort of things influence how much we want of, say, salmon fish? Take a moment and think of what types of things influence your demand. So when I think of salmon fish, and I think of going to the store, there are lots and lots of things that I think are apparent in their influence of my demand for that product. First is price. If there's a sale, I'm going to buy more, and if there's a price increase, I'm going to buy less. Second, you might think taste. Maybe you don't like salmon fish. If that's the case, you will probably buy less. Another thing you might think about is the prices of other goods. Some goods are complements, some goods are substitutes, and this has an influence over the quantity of salmon fish that we will buy. Also, your income level will influence how much you buy. For most goods, the more money you have, the more of them you can afford, therefore the more of them you will buy. Lastly, and it's easy to forget, rules and regulations play a role as well. If the government mandates that every man, woman, and child must consume 1 pound per week of salmon fish, that will have a measurable impact on our salmon fish consumption. Now, I mentioned the price of other goods, and it's important to pause for a moment here to remind you that the effect of other goods on the consumption of some related product could either be substitutes or complements. Substitutes are goods that we think are similar to one another and therefore might be used as a substitute. For instance, you might think that, the price of codfish is really low. Maybe I don't need any salmon fish. Complements, on the other hand, are different things that we think go really good together. For instance, if you picture, a nice summer grilling out, maybe you like to eat your salmon fish with some corn on the cob. If the price of corn on the cob goes up, maybe you'll eat less salmon fish. Once we have in our mind the quantity demanded, we might want to extrapolate this to something slightly less concrete. We'd call this less concrete relationship between quantity and price demand. I say it's more abstract because we can't really observe demand. At every moment in time, given price, income, all the other things, I can observe quantity demanded, but how does quantity demanded react to changes in the different things that influence quantity demanded? This is something that we can't directly observe. However, I would say it's more useful because it allows us to think about how things change when there's an influence on some of its factors. And the most easy way to think about the quote-unquote demand function is through the demand curve. The demand curve is just a plot of the quantity demanded of one good against its own price. We'll hold all other variables constant. And also, by convention, let's just let Q, i.e. the quantity demanded at each price, be put on the x-axis, and we'll let P, i.e. the price of the good in question, be on the y-axis. Then, continuing with our fishy example, assume we live in a world with just salmon fish. Let the quantity demanded be given by 200 minus 50 times the price of salmon. If this is the case, what is your demand curve? Take a moment and try to sketch it out. So if I were to sketch this, first thing I would do is try to find the intercepts. If my price is 0, it appears that they would consume 200 salmon fish, so that would be our intercept on the x-axis. Similarly, if the price of salmon were $4 per fish, it appears that 200 minus 4 times 50 equals 200 minus 200 equals 0. Therefore, our y-intercept, i.e. the intercept for price, must be 4. Therefore, since the relationship is given by a negative 50p, we know that this is a straight line between 0 quantity 4 price and 200 quantity 0 price. Hopefully what I got looks like this. Although that was fairly simple, there are some additional questions we might ask. For instance, well, at what price might someone demand 2 salmon? Take a moment, think it out. So if it were me, I would say, well, I know that my quantity equals 2, and that's equal to 200 minus 50p. Rearranging, I would note that 50p equals 198, so p equals 198 out of 50. Another question we might ask is, well, how many salmon would somebody demand if the price is 1.5? Solve it out. If this were me, I would go Q equals 200 minus 50 times 1.5 equals 200 minus 75 equals 125. Another thing you might ask is, well, what is the slope? And what does it mean? Think it over. When I think about the slope of this line, I note that for every $1 increase in P, the quantity will decrease by 50. So that tells me that this slope gives me the direct relationship between price and quantity for salmon fish. The other thing you could do is try to work in reverse. Here is a different graph of the demand for salmon fish. What demand function does it show? So the first thing I would note is that if my price is 0, I demand 150 salmon fish. So I know that the x-intercept is 150. Next, if the price of salmon fish is $8 per fish, then it looks like it is 0 demand quantity. So therefore, it must be 150 out of 8 as the y-intercept. Different things would influence our graph. First, trying our own. What would happen if there was a change in the salmon fish price from 1 to 150 per fish? First, how would we graph $1? 2, how would we graph a change between $1 and $1.50 as the price? So you'll note that if we look on the y-axis, that traces out the different options for price. Midway through would be $2. Quarter of the way through would be $1. So a line horizontally from $1 would give me approximately the demand if the price was $1 per fish. Now, if the price were to increase, to me that would just be a vertical displacement of this line to somewhere around $1.50. Let's think about some non-price related changes. Assume there is news of mercury poisoning in our fish, and for that reason, people just want less fish. And also, to make this very concrete, let's assume that we think people just demand 1 fewer fish at any price. How would this change our graph? So, by the description, it says we want 1 less fish at any price. So that means at the price of 0, I would want 199 fish. Similarly, at the price of 1, I would want 1 less fish. At the price of 2, I would want 1 less fish. At the price of 3, I would want 1 less fish. So this to me suggests there would just be a leftwards movement of this curve of a magnitude of 1. You will note that this line has visually moved both leftwards and downwards. It is important to make the distinction, though, that this is a leftward shift because we have changed the quantity of fish demanded, i.e. our Q, which is on the x-axis, denoted by left and right, and not P, which gives us changes in the up and down direction. So, because there is mercury poisoning, our demand curve has shifted left by one fish. Other thing we could talk about is the quantity supplied. Like the quantity demanded, quantity supplied is the most concrete example. This is just saying, well, how many salmon fish does a firm want to sell, holding constant all the things? Think for a moment what sort of things influence the quantity a firm will want to supply of a given object. Note, these will be different things than the things that influence the quantity demanded. So when I think about quantity supplied, I think about things that will cost the firm money. So the most obvious thing that will influence the quantity supplied is input prices. If fish nets and boats and labor hours and lures and bait all become more expensive, firms will want to supply less fish. Similarly, if the government mandates that fishers buy some commercial fishing license in order to supply us with fish, that will change the amount of fish they supply as well. And in this way, regulations, we believe, are also important. And just as before, we could either talk about quantity supplied or the more abstract relationship between the quantity supplied and the price. You will note here that we typically assume the quantity supplied increases in price. Since the price is the amount that a firm takes in for every unit of fish that they sell, they will want to sell more and more fish as the price goes up, because then they can afford more and more expensive inputs. So it's more and more appealing for them to sell fish. Also, as we could with quantity demand, either work with a demand function or a demand curve, we can do the same with supply. And we can go through the same exercise of mapping between mathematical equations and graphical diagrams, but I will say that doing this with quantity demanded was good enough. And as before, we can also think about different changes. For instance, take a moment and think about how we might, for instance, graph changes in quantity supplied if we were to change the price from $4 to $4.50 per fish. That the price is $4, you'll see that denotes a unique quantity supplied. And if the price increases to $4.50, the quantity supplied will have increased. Similarly, we can talk about non-price changes in supply. For instance, let's say fish becomes harder to catch, and to be simple, let's just assume that they catch one fewer fish, regardless of the price. Original supply was Q equals 4 plus 3P. How do we change this graph such that the fishermen are now catching one fewer fish, regardless of price? As before, it's important to look at the axes. Let's say the price is given at this level. If they were to catch one fewer fish, it looks like, given this fixed price, they would be somewhere left of the original quantity supplied schedule. Similarly, if the price were 0, it looks like they would supply one less fish. We can do this all the way up and down the line, and therefore, it'd be easy us to project all of these points by just drawing a parallel line slightly to the left of what we had originally. Importantly, this graph has shifted slightly to the left. It is important to note this because we also could equivalently notice that it appears this line is higher than this line, but we would not say that supply has increased. This is why it's important to look at the axis. When we read the story, we say, fish have become harder to catch. They are catching one fewer fish. We're talking about a quantity of fish that is a movement on the x-axis, so this is moved left on the x-axis, and not up on the price axis. Next thing we could do is imagine putting these two components together and combining supply and demand to think about the quantity of fish that this market should provide and at what price in equilibrium. How could we find such a point? You might remember from your principles of economics that we were taught just to always look at this intersection. And while that is the correct answer, it's important to take a moment and think about why that is the answer and not some other point. For instance, ask yourself what would be wrong if the market arrived at point A, i.e. some price higher than equilibrium and some quantity that was lower. What would the market look like and how would it respond? Well, if we were at point A, you will notice that the price is way too high. Also, you will note the demand is far exceeded by the supply. This tells us that suppliers are supplying lots and lots of fish. There would be fish piling up on the docks, getting very smelly. And also, people would not want to buy them. This would incentivize some of the fish suppliers to want to lower their price to get rid of some of those smelly fish. So, we could picture them slightly decreasing the price. You will note that the gap between my initial point at A and the equivalent point on the supply line is slightly smaller after I decrease the price. So, they will note at these new 2 points that there is still an excess of fish, and they'll respond again by decreasing price, hoping to get rid of some of these fish. They will repeat this action until they note that all of the fish that are piling up are now selling, and they will only be able to sell new fish by decreasing the price. Therefore, this high price with low demand cannot be the equilibrium because suppliers will rationally respond by decreasing price until all their fish have sold. Similarly, take a moment and ask yourself, what would be wrong if we were to start at point B? Well, at point B, you will note that the quantity supplied is very low and the quantity demanded is very high. So picture all these salmon fish sellers at the end of the day would have lines and lines of people saying, hey, I want some more salmon fish. Rationally, you could see these salmon fish sellers rubbing their hands together and thinking, ooh, I could make some more money. How can they make more money? Well, just increase the price of the fish they've sold. You will note that as they increase the price of the fish they've sold, they can now supply more fish. They can afford more inputs, and therefore the quantity supplied will increase. Similarly, as they increase the price of fish, some people will say, at that price I don't need any fish. And so the gap between quantity supplied and quantity demanded will shrink. This shrinking of the salmon fish shortage will continue until they reach the point at which supply and demand are equalized, i.e. at the equilibrium. So, although this intersection is indeed the equilibrium, and we know that we can find it easily by looking at where supply and demand intersect, it's important to note also that very specific things will be incorrect at any other point within this plane. The next question we might ask is, well, if we had supply and demand, how could we mathematically find the equilibrium? Pause the video, take a moment, and see if you can find for yourself at what price and quantity supply and demand are in equilibrium. So if I were to solve this, I would note that the quantity supplied has to equal the quantity demanded. That is, 4 plus 3p must equal 20 minus 3p, i.e. 6p equals 16, 3p equals 8, or p equals 8/3. So we know that the price must equal 8/3. Next question is, well, at what quantity will the price be 8/3? You might ask, well, should I plug this 8/3 into quantity supplied or into quantity demand? Well, importantly, we just proved that when the price is 8/3, these two equations will be equal, therefore it shouldn't matter. So we know that the quantity supplied, which must be equal to the quantity demanded, must be equal to 4 plus 8 equals 12. Next, we might ask, well, what happens if we set the price incorrectly? What if the price was greater than 8/3? What if the price was less than 8/3? Well, let's go back to the graph we had before. We know, this will go back to the graph we had before. we know that when the price is 8/3, quantity supplied and quantity demanded are equal. So, if we set the price to be above this, we would note that demand were too low and supply were too high. Since demand is decreasing in price, the price would be way too high, and we'd end up with too few fish demanded. Similarly, since supply is increasing in price, the price being too high would cause us to have too many fish supplied. By similar reasoning, we would note that if the price were set too low, supply would be insufficient and demand would be too much. And that's all we have. Thanks so much for your time, and see you next time.